Hello everyone, my name is Panaganti Meenakshi. I am from Jawaharlal Nehru Technological University, Hyderabad. I am currently pursuing my electrical and electronics engineering over there. This video is a presentation video of covering what I have learned and implemented during the online free IoT internship program offered by EMERTXE. In this internship program, I have done a project which is IoT based home automation solution. To implement this project, the software I have used are Arduino IDE, PiximLab, Remote Serial Port Server, and Blink application. The first week of this internship program was mostly about the coding part, which is learning about C programming, wherein the instructor clearly explained about data types, modifiers, arrays, functions and pointers, then some introduction about C++ and OOPS concept. And from the second week of the internship program, the first thing I learned was coding in Arduino IDE application and then connecting that code to the microcontroller present in PiximLab application, which is used for the simulation. The microcontroller we used is Arduino Uno, and the first code I have written is blinking of LED. So this is the first code I have written in the internship program, wherein we have decided the pin mode to be output and the pin to be 13. The LED will be on for 1000 milliseconds and will be off for 1000 milliseconds. We will go to modules and spare parts. We'll add the LED. Since we are using only one LED, we can decrease the size of this spare part by using this. We have to set the pin to 13. Then place it here. We load the hex file of this code, which is blink. The LED will be glowing for 1 second and it will be off for 1 second. That is the first program we have written in the internship. And then the instructor taught us about spare parts present in the PiximLab like sensors, CLCD displays, etc. What we have written for the working of CLCD display, we have to go to modules and select the spare parts. I have already selected the CLCD display. We will connect the SCL to pin A5 and STA to pin A4. Now we'll upload the hex file of the written code, which is CLCD. Since I have given the in the code that at the point 3 and 0 the EMERTXE will be shown, and at the second row internship will be shown. As we can see, we have the same. And then we started to write code for the small components of the final project. We learnt about displaying the temperature on the CLCD and then glowing of the LED, and then about serial tank. And she taught us about Blink app, wherein we can connect the simulation program to the mobile application and control the switching of LED. And at the final, we learnt about tailoring all these components together and building the final project. And we connected all the simulation to our mobile application and easily control the simulation program and see the readings of the temperature and volume in the serial tank through our mobile application easily. Now we'll see what were the project requirements and how we have implemented these using Arduino IDE and PiximLab. The first requirement of our project was garden lights control, wherein the Arduino Uno has to read the sensor value from the LDR and control the light's intensity. The This is the Arduino IDE code we have written for the garden lights requirement, wherein we have defined the LED pins value as A0 and we have connected the analog pin of LDR sensor to A0, and at the LED pin value is 3, the similar is done in the PIXM lab. And then we have written the code for the void setup, wherein we have defined the pin mode of the LED as output, and in the loop we have defined the working of LED so that it works as per the requirement. Now we have to load the Arduino file in the PIXM lab. After loading, we can see that when the LDR's value is high, the intensity of the LED is more, and when the LDR sensor value is very less, the intensity of the LED is decreasing. This is the first requirement for the project. Second requirement of our project is temperature control system, in which the Arduino Uno sends the temperature display to the CLCD and CLCD shows the display. The temperature system reads the temperature of the surrounding and sends the signals to the Arduino. All of this will be connected to Blink IoT app, where we can see the display of temperature and we can control the pins of cooler and heater, which is used for decreasing or increasing the temperature. Without integration of Blink IoT, we have the code that is the code is we have included wire.h and liquid crystal display for the displaying of LCD, and then in the setup code we have initiated the code for LCD, and in the loop we have given the formula for the temperature to show in degrees Celsius. Now when we load the and for the connections of LCD are the SCL is connected to A5 pin, the SDA is connected to A4 pin, and the temperature system is connected to A0. Now when we load the hex file of this Arduino code, we will see the output. The temperature is displayed as 27.34 as it is of the surrounding. We have defined it initially. Of our project was water tank inlet and outlet. The third requirement of our project is water tank inlet and outlet valve control. In this, the water tank gives the amount of volume in the water tank to the Arduino Uno, and through Arduino Uno we can control the inlet valve and outlet valve, and all of the volume in the tank is displayed on the CLCD. We can control the switching of inlet and outlet using Blink IoT app. For now, I will show the Arduino IDE code we have written and the serial tank working. This is the Arduino code we have written, wherein we have included the I2C display for the amount of volume in the tank, and we have defined the values of inlet and outlet. For 00 it is on, for 01 it is off, and we have enabled and disabled the inlet and outlet. Now in the LCD we will display the volume of the tank. To see the simulation, let's load this Arduino file into the microcontroller. Then we'll open the serial remote tank, connect it to COM4, then again we'll load the file. We can see that the inlet is on, and we can see that the volume of the water is shown on the LCD display. After a particular point, the outlet switch is enabled, as we have defined in the code. Of our project is interfacing the Blink application with the simulation. For doing that, we have created a Blink account, wherein we have to go to developer zone, create our template. I have created my template as intern. Here we have defined all the interface data streams like heater control, temperature control, cooler, volume, inlet and outlet. Now I have also created a web dashboard for this. Uh, for this for this we have also created an app, um, mobile application for this. For now, this is the web application. We have created it using edit option and we have selected the switches, gauge and everything. This temperature will show how much temperature is shown on the simulation. This volume will also do the same. Whenever we on the cooler switch, the temperature goes down, and whenever we on the heater switch, the temperature will go rise up. Same with the inlet and outlet switch. We have saved and applied it. We will go to devices. We will see if the device, we'll upload the code in the Pixim lab and we can see if the device is online and we can read the readings from here itself. Mobile interface which I have created using Blink. This is the heater switch which can be on and off according to our requirement and through which the temperature is controlled. The temperature display is shown here. The volume display will be shown here. The outlet and inlet of the tank can be controlled through these switches. Now we'll see the working of our final project. These are all the codes we have written in Arduino IDE. We have defined our Blink template wherein these are all taken from the Blink application itself. We'll go to devices and settings. We can find all of this here. This is used to connect our simulation with the Blink. Then we have defined all the libraries we have included in this project. Liquid crystal display, SPI and Ethernet is used to connect the Arduino board to the internet, and Blink is this library is used so that we can use Blink in our code. These four are the main codes we have written which will be used here. The serial tank is used for controlling the volume in the tank. The main file contains all the virtual pins we have given in Blink application. The LDR sensor, LDR code contains the code of LDR sensor and LED. The temperature system has the code of temperature system code. Then we have created 4 switches: heater, inlet, outlet and cooler switch, which we use in the Blink app to control the simulation. We have defined all the virtual pins of cooler, heater and inlet and outlet here. Then we have initiated all the LDR, temperature and serial tank codes over here. In LDR CPP we can see the function init underscore LDR. This is initiated over here, and then we have temperature initiation here over here. Then we have initiated the LCD, then the serial tank. We have defined all these pins. The same pins are used in the Blink wherein we have defined the data streams of our project. The same V0 to V5 pins are defined over here. Then we have created the whole simulation program over here. This is the LCD display wherein we will see the volume of the water, the temperature of the system, and we'll see whether the heater or cooler is on or inlet or outlet is on. This is the Ethernet shield we are using to connect the Arduino to the internet. This is the LED which is controlled by the LDR sensor. This is the serial tank wherein we will see the volume of water. It is a simulation used to see how much volume of water is there in real time. This is the temperature. We are controlling the heater and cooler using our mobile application. We'll first connect the serial tank with COM4. Then we'll load the hex file. We can see that the temperature is 27.4 and 0. Similarly, in the application, we have the same reading. Now, we'll on the inlet, we can see that the inlet is on and the volume of the inlet is changing. We'll see what will happen if heater is on. We'll on the outlet also. You can see that the volume is decreasing.